So, hello my dear student, how are you? So today we are going to discuss lecture number 15, right? Lecture number 15, and today's topic is NC-CNC, and this is the first lecture of NC-CNC. Now, in today's session, we are going to discuss okay, these topics. What is NC-CNC? Difference between NC-CNC and basics CNC principle, right? Now, let me start this topic, right? Let me start this topic. Yes. So, see here. So, first of all, my dear, what is NC? NC basically, here, NC, right? Here, the meaning of NC, numerical control, right? Numerical control. Numerical control, right? Numerical control. And CNC, the meaning of CNC is computer numerical control. Computer numerical control, right? Computer numerical control, right? Now, let's move. What is the difference between NC and CNC, right? What is the difference between NC and CNC? What is the difference between what is the difference between NC and CNC? My dear, there is a huge difference in between NC and CNC, right? There is a huge difference. The earliest NC machine perform a limited function and movement controlled by punch tape or punch cards, right? So let me write down the point. The earlier numerical machine, right? The earlier numerical machine yes, here this is the point, please note down. Earlier NC machines, right? Earlier NC machines performed limited function. Performed limited function, right? Limited function. They have a limited function. Please note down. They have a limited function, and movement is controlled by what? Movement is controlled by punch tape or punch card, right? Punch tapes or punch card, right? Punch card. So this is the very important thing, right? Limited function and controlled by punch tape and punch card. This was the thing which we use in the earlier machine. Now, as the technology evolved, the machine were equipped with increasingly powerful microprocessor, right? As the technology developed, okay, the machine were equipped, or you can say when the machine were equipped with the increasingly powerful microprocessor, when the machine right, when the machine were equipped, machines were equipped, right? Machines were equipped with increasingly powerful, powerful microprocessor, microprocessor, which you call so-called computer, right? Which you call what? So-called, basically we are talking about what? Basically we are talking about computer, right? So when you attach a computer, that is a highly microprocessor, right, to the NC machine, now that machine become what? CNC, right? That machine become what? CNC. Is that clear? So CNC has a various, CNC has, my dear, CNC has various functions, right? Now the question is, now here the question is, do all machines speak the same CNC language? Now here the question is, do all machine speaks, do all machine, right, speaks, okay, basically we have to do some coding, right? We have to do some coding. Speak the same CNC language, speak the same CNC language, right? Language, is that? The answer is no. The answer is what? The answer is perfectly no, my dear. The answer is perfectly, what is the answer? The answer is perfectly no. Now you say, why, sir? My dear, you know, CNC is always in the modification stages, right? uh, Always there is a modification stages, so that's why software or the languages are also in the developing stages, right? Every time you use a developed language, okay, you you neglect the, basically you avoid the previous languages. Instead of that, you use the modified user friendly languages coding, right? So while there is a fairly standard set of G and M code, there is some variation in the application, right? Earlier, okay, there is application. For example, let's say there is a code GOO, right? GOO or G00 command. G00 command earlier, basically nowadays, right? In new CNC, my dear, in new CNC, right? Let me write down earlier, or let me write down earlier or old CNC. Let me write down old CNC. Old CNC, right? In old CNC, suppose that I have to move the tool from that point to that point, right? I have to move the tool. I have to move the tool from here to there without doing any operation. So that's why I'm representing with the dotted line. So here the tool is moving with a very rapid speed, rapid travel, right? Rapid travel means the tool is moving from point A to B but not doing any operation, only movement is there. Rapid travel means tool is moving with its fastest travel speed, right? With its fastest travel speed. So earlier this rapid travel command is given by capital F, right? Earlier this rapid travel command is given by what? Is given by capital F. But now in new CNC, my dear, in new CNC machine, right? In new CNC, right? CNC machine, suppose again if you want to move the tool from here to there, right? From here to there, now the tool is moving from here to there. Here you can see again it is moving from point A to point B. There will be a rapid travel, right? Again you are doing what? Rapid travel. Again you are doing a rapid travel. So now we are introducing a new user friendly command, that is what? G00. In short, you can say go. So go means what? You are moving from one point to another point in a very rapid manner, but technically it is G00, right? Now in new CNC machine, okay, in new CNC machine we are moving our tool from here to there, and suppose you are doing any operation, so represent by a solid line. Solid line means what? You are doing some operation, continuous operation. Here no operation is there in the movement. Now you are moving, okay, now you are doing some operation. Here operation is there, my dear. Here operation is there, right? Operation is there. So here during operation, suppose that you are doing a arc welding from here to there, right? During arc welding, you are not you have seen that you are not moving your electrode from one point to another point with a very high speed, right? You are moving with some feed, okay, that is f. F has some value, so here f represent as basically what? Feed rate, right? In new CNC, f is used as a feed rate, right? So this is a modification. That's why my answer is what? That's why my answer is what? No, right? My answer is what? No. Now let me ask you one more question, my dear. Let me ask you one more question. Are all CNC machine, okay, let me ask you one more question. What is conversational control? What is conversational control? Conversational control. What is conversational control? My dear, conversational control, basically it is a display, right? Let me draw. Suppose that this is your computer screen, okay, and in that computer screen, this part, let me show you. Here you have done some coding work, right? You did some coding work. Here you have did some coding work. See, you have did some coding work. You have did some coding work. You have did some coding work. See here, you have did some coding work. This is a coding, right? This is a coding. So here there is a graphical display. Basically here there will be a graphical display, graphical display, right? Graphical display. There will be a graphical display. So whatever you have written there, this is going to be, this is going to be see in the screen. You can see all the movement of the tool on a screen. So CNC machine, this function is only available in CNC machine. CNC machine tool builders offer an option that is known as conversational control. This is a conversational control which I am talking about. This is a conversational control, conversational, right, control, conversational control. So whatever you have done, this is a coding, my dear. This is what? This is a coding or a language which you are using for the movement of the tool. That language is going to be converted into some display, a graphical representation of the tool. That is a conversational control. So CNC machine tool builds offer an option that is known as the conversational control. This control lets the operator or programmer, this here, let me write down, right? Let me write down, let me write down, let me write down, let me write down, let me write down. Here, this, right? This controls, this controls, okay, this controls, let the operator, my dear, let the operator or programmer use simple descriptive language, use simple descriptive, all the language which I have written here, simple descriptive language, right? Descriptive language, whatever the language we have written there, that simple descriptive language to program the part, okay, to program the part, right? To program the part. So the control then display, the control then display, right? Then display what? Then display a graphical, displayed a graphical displayed a graphical representation of graphical representation, my dear, of the instruction, right? Of the instruction of the instruction of the instruction of the instruction, whatever instruction you have written, that is going to be converted into the graphical way, right? Graphical representation of the instruction, so that operator programmer can verify the tool path. Is that clear? This is the basic concept, right? This is the basic concept. Now the next question is R, my dear. Generally students are confused in this question. Question is, are CNC machine faster than conventional machine? Are CNC machines are faster than conventional machine? Conventional machine, yes or no? Tell me. Conventional machine, sometime yes. The answer is yes, right? The answer is yes and no. It depends on the case. The answer is yes or no. Yes, the answer is yes and no, my dear. The answer is yes or no, right? The answer is yes or no. Why? Suppose that, what is the question? Are CNC machine are faster than conventional machine? Yes or no? Suppose that if the part is complex, suppose that if the part produced is complex, right? Complex, my dear. What is a complex means? Let's say any part. Okay, let's say I'm drawing any path, any part. I'm doing any part. Here, this is a part which I'm drawing here. See? Now you have to produce that part, right? Now you have to produce that part, my dear. There is a tool. Please see, there is a tool, right? Now here you have to provide the feed to the tool. Okay, in basically, let's say this is a x direction, right? And let's say it is the y direction. So this is what x and this is y. You can see that the feed of the tool is not given in the x direction or y direction. Okay, it is given in xy direction. So here the feed is in what? Xy direction. So the movement of the tool is very difficult. If you use a conventional machine, then it is very difficult to maintain this shape. In that case, your conventional machine, your CNC machine is faster. If you want to produce a complex shape, then your CNC machine is faster, because CNC machine has some motor which can maintain the feed in x direction, y direction. Overall the feed is going to maintain in xy direction, my dear, right? So CNC become faster because if you maintain the feed manually. Because if you maintain the feed manually, then there will be a chance that either the x direction or y direction feed is going to be what? Disturbed, right? Either the x direction or y direction feed is going to be what? Disturbed, right? So that's why here CNC machine is faster. So answer is yes, CNC machine are faster than, okay, conventional machine. But my dear, if you are producing a very simple part, let's say we are doing a turning operation. Let's say we are doing a turning operation. Okay, let's say we are doing a turning operation. This is a turning operation. Here, okay, here this is a turning operation. Here you can see a turning operation is there. There is a turning operation. The tool is there. Here we can see that there will be a tool. Right, there is a tool. Right, this is a tool. Now here you can see the movement of the tool is maintained only in x direction, right? We have to maintain the feed in what? We have to maintain the feed in x direction only, right? We have to maintain the feed in x direction only, not in y direction. So if we are producing a simple part, right? If we are producing a simple part, right, then 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 conventional machine is hard to beat. In that case, your conventional machine is faster compared to CNC, my dear, right? So here conventional machine is faster. So the answer of this question is what? No. Are you getting? Are you getting? Are you getting my point? Yes or no? Okay. So let me write down this point. Let me write down this point here. Okay, let me write down this point here in a language form so that you can understand this thing, right? So that you can understand this thing, right? So that you can understand this thing. So let me write down. Now you understand the logic now. Here I'm going to write down the reason. When it comes to, listen me, when it comes to make a single simple part, when it comes to be, listen me carefully, when it comes to making a, when it comes to making a single, right, single simple part, single simple part, right, single simple part, it is hard to beat a conventional machine. It is hard to beat conventional machine, hard to beat conventional machine, right? Hard to beat a conventional machine, my dear. Hard to beat a conventional machine, right? Like lathe, milling, etc. CNC machine moves faster in rapid travel than conventional machine, right? When when it comes, right, when it comes to make a complex part, a complex part, it is hard to beat CNC machine, hard to beat CNC machine, my dear. CNC machine. Is that clear? Is that clear? Okay, is that clear? So I hope this point is crystal clear to everybody, right? Everybody. Now again the question is come, sir, whether whether we produce a complex part or a simple part, let's say from CNC. Okay, what you can say about the accuracy? Right? Let's say if you are producing a part in CNC or as your conventional machine, my dear, accuracy is very good in CNC machine, right? So my question is what? Are CNC machine more accurate than conventional machine? The answer is what? Yes. So my next question is very simple. My next question is very simple, that are CNC machine faster than, are CNC machine, here the next question, are CNC machines, right? Are CNC machines more accurate than, more accurate than conventional machine, conventional machine, right? Conventional machine. Yes or no? The answer is here. The answer is what? The answer is, my dear, here the answer is yes. Here the answer is what? Yes, my dear. Right? Yes, they can be. Okay, but like anything else, it depend on who is running. Suppose that the machine is good, but the operator is not good. Operator is not experienced, then it is worthless. So it depends who is running the machine, how well the machine has been maintained, quality of setup, and so on. But overall, you can say accuracy produced by CNC machine, okay, is more accurate than your conventional machine, right? Your conventional machine. So this is the point. I hope you people understand this point, right? You people understand this point. So let's move to the next point, my dear. Let's move to the next point here. Let's move to the next point. let's move to the next point here. Now let's move to the next point here. Please see. Please see. NC, CNC. Now there is a term of DNC, right? DNC. DNC. What is the DNC, right? So let's discuss about the DNC, my dear, right? Let's discuss about the DNC. Okay, so what is the DNC, my dear? DNC basically distributed numerical control, right? Distributed distributed numerical control. Distributed numerical control, right? Numerical control. Distributed numerical control basically is a system that use a central computer to control several machines at the same time. Let me explain you the problem first of all. Okay, problem first of all. Suppose that there will be a main computer. This is what? This is the main computer, right? This is main computer, right? And it has its memory. Okay, and here this is the memory. Here memory, right? In that memory we hold all the data. Now that main computer give the order to the different NC machine, right? That main computer give the data to different NC machine, my dear, right? NC machine. Please see here. Please try to understand the concept which I am explaining here. So this is the NC machine. This is the NC machine. Okay, this is the NC machine. Here, try to understand the concept, right? Try to understand the concept. Try to understand the concept. Try to understand the concept. Now see. This is the NC machine, right? This is the NC machine. This is what? This is NC1. This is what? NC2. And this is what? NC3. Now you have sent the direction to the individual NC machine for the operation, right? So you have sent it the direction. Now if during operation, if any problem is come, then feedback is sent. Then feedback is sent to the main computer, my dear. Then feedback is sent to the main computer. Then feedback is sent to the main computer, right? Then feedback is sent to the main computer. Then feedback is sent to the main computer. After that, if the feedback is resolved, then again the direction is sent, right? Again the direction is sent. Again the direction is sent. See, again the direction is sent. See, again the direction is sent. See, again the direction is sent, right? Again the direction is sent. My dear, please see. Please see, if you have noticed, in front of the main computer there is lot of traffic. In front of the main computer there is a traffic, right? There is a huge traffic, right? There is a huge traffic. Along with that, the main computer has to store the file of each NC machine, right? Each NC machine, NC1, NC2 and NC3. So this main computer has to hold the data of each NC machine. This main computer has to receive the data, have to take the quick decision, and again have to send the direction. So lot of traffic will be built up. Lot of traffic will be built up, my dear, right? So the speed of the system is slow, right? File can be, it is difficult to handle the file in a single main computer, my dear, right? So instead of that, what we use a distributed numerical control. This is my main computer, right? This is my main computer. Okay, this is my main computer. This is a memory section, right? Now this main computer is attached with what? Attached with your CNC machine. Here, my dear, there will be a CNC machine, right? There will be a CNC machine. There will be a CNC machine, right? There will be a CNC machine. See here, see here. There will be a CNC machine. There will be a CNC machine. Here, try to understand the concept which I am telling you. It's a very good concept which I am telling you, right? Very good concept which I am telling you. So here, this is what, my dear, CNC, right? CNC 1, CNC 2, CNC 3, let's say. So CNC has its own computer. CNC has its own computer. When you send the direction, my dear, when you send the direction, 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 when you send the direction. Now, whatever the direction you have sent it now, this CNC machine operation will do on its part. Feedback will go, right, and again direction will come. Similarly, direction, right, feedback to its own computer, again the direction. Similarly, direction, feedback to its own computer, then direction. So feedback and direction will be, okay, communicating with its own computer. Okay, NC and computer communicate to each other. At the end, result will be sent to the main computer. At the end, result will be sent to the main computer, my dear. So this is the concept of DNC. Here the speed, overall speed is going to be what increases. Okay, overall speed is going to be what increases. So distributed numerical control is a system. Let me write down, is a system, right, is a system that uses a central computer. Okay, that uses a central computer, that uses a central computer, right, uses a central computer, that uses a central computer, okay, to control several machine, to control several machine, to control several machines at the same time, at the same time, at the same time, my dear, right, at the same time. So overall the advantage, in DNC is what? Here the speed of the system is increased, right? So have you understood in the DNC? The central computer download the complete program to the CNC, right? Let me explain you again. The central computer download the file to each CNC, right, which can be workstation or PC, and can get the information for the machine operator, right? So overall in this DNC, system, my dear, right, overall in this DNC system, the speed of the system is the speed of the system increases. The speed of the system is increased, right, is increased, right, and here it is easier to maintain the large file in its own CNC, right? Here the large file can, because it is a computer. Here is a computer, highly microprocessor. So in this memory, file can save, right? File 1, right? This is file 2. This is file 3. So individual computer, we can save the file, right? In main computer, we have to save all the files. So it is easier to handle. So large file can be handled. Here you can write down that large file can be handled, right? Can be handled. Large file can be handled, and number of machine tool and number of machine tool, number of what? Machine tools, right? You can attach number of machine tools. Okay, number of machine tool used is expanded. Tools used is expanded, right? Expanded. Use is expanded, my dear. So I hope this point is crystal clear, right? I hope this point is what? Crystal clear. Okay. So now let's discuss a very important concept, that is a stepper motor, right? A stepper motor is a very useful concept which I'm going to discuss here. So please see here the stepper motor, the concept of stepper motor, right? Stepper motor, the concept of stepper motor. Now, what is a stepper motor? A stepper motor, basically it is a synchronized motor. It is a synchronized motor. The stepper motor is a special type of synchronized motor which is designed to rotate through a specific angle, which is called a step for each electrical pulse received from the control unit. Suppose that this is a control unit or computer, whatever you can say, right? And this is a stepper motor, or okay, and this is a shaft, right? Now from the central main unit you have sent it some electrical pulse, right? This is the main unit, my dear, right? This is what? This is the main unit. Okay, this is the control unit. This is a control unit or main unit from where we have sent it some electrical pulse, electrical pulses, okay, to the stepper motor, Now this is a special type of motor. When the electrical pulse is received by the stepper motor, then the shaft or lead screw, this is what, let's say shaft or lead screw, right? Lead screw will rotate through a specific angle. So let me write down here in the language, right? Let me write down this thing in the language, my dear. Okay, please try to understand. Please try to understand this point. Now, try to understand. The stepper motor is the stepper motor is what? The stepper motor is a special type of synchronized motor. Okay, synchronized motor. Okay, synchronized means this is a special type of winding. Synchronized motor. We are talking about this motor, right? We are talking about this motor, synchronized motor, which is designed to rotate, which is designed to rotate through a specific angle, right? Through a specific angle, my dear, right? Called step. Called what? Called step. We call it a step. Okay, for each electrical pulse. For each electrical pulse. For each electrical pulse. For each electrical pulse received from the control unit. Received from the control unit, right? So I hope you understand the concept of the stepper motor. Now there are two types of, there are two types. I mean, there are two types of system, which is very important. Closed loop open system and open loop system. So let me write down the open loop system first, right? Open loop system first. Try to understand the open loop system. Open loop system, right? Open loop system. Now, in the open loop system, there will be a control unit. Okay, there is there is a stepper motor. There is a stepper motor, and stepper motor is connected with a shaft, right? With a lead screw. Okay, on the lead screw there will be a nut, and on the nut there will be what? There will be a table, and on the table there will be a workpiece, right? Now let me explain this concept. Now this is the electric pulse. This is what? This is electric pulse. Electric pulse. This is what? Electric pulse. Now here this is stepper motor. Stepper motor, right? Now this is a lead screw, right? This is lead screw, right? When the pulse is received by the stepper motor, lead screw will rotate. This is, my dear, nut, okay, and it will do a linear motion, right? And it is a table, right? Table, and this is what? This is the workpiece. This is what? This is the workpiece which move, right? So this is a open loop system, right? This is the open loop system. Now there is a closed loop system. Now there will be a closed loop system, my dear. Let me write down the closed loop system. Closed loop system. My dear, in closed loop system, there will be what? There will be a motor. This is a servo motor, not a stepper motor. Okay, servo motor. The function of servo and stepper is almost same. Okay, little bit difference is there. Basically, in stepper motor, when you do operation, when the operation, right? When the operation, when the operation, right? When the operation is point to point, right? When you're doing the operation, that is what? Point to point, then we use a stepper motor, right? Then we use what? Then we use a stepper motor, right? Like spot welding, example. Example is what? Like spot welding, right? Like spot welding. This is the example. Point to point, point to point, point to point, point to point. Like what? Like the spot welding. Clear? Now, when you are doing a continuous operation, then we use a servo motor. Let me write down. This is a servo motor. This is a lead screw, right? This is a nut, right? This is a nut, and this is what? This is a work table, right? And this is a workpiece, right? This is a workpiece. So here, this is again, I'm going to write, this is what? Lead screw, right? Lead screw. This is nut, right? This is nut. When the servo motor receives the electrical pulse from the main unit, there is a converter also. This is called DAC. There is a converter which is called as DAC, and this DAC is attached to the main or a control, okay, or a control unit or a comparator. Control unit. This is control unit, right? This is a control unit. Now control unit send the signal through DAC, and DAC will send the signal to servo motor, right? Then that servo motor will rotate the lead screw through a specific angle. Nut will do a linear motion. Work table will do a linear motion. Workpiece will do a linear motion with respect to what? Tool. Now at the end, there will be a optical encoder, my dear. This is what? This is optical encoder. This is what? This is the optical encoder, right? This is an optical encoder. Basically, it is nothing that it is a feedback device. This is known as optical encoder. Optical encoder, right? This is the optical encoder. This optical encoder basically send the feedback signal, feedback signal, right? Feedback signal to the main or control unit, right? So when we use the servo motor, when the operation, let me write down, when the operation, when the operation is, when the operation is continuous, right? When the operation is continuous, right? So when the operation is continuous, example is what? Like arc welding. If we are doing a arc welding, that is a continuous operation, then in that case we need what? We need a servo motor. So please remember that this concept, right? Please remember that concept in a very well manner. I hope the point is clear, right? I hope the point is crystal clear. Okay, so in the next lecture, my dear, in the next lecture we will discuss the basic length unit, right? We will discuss the next topic in the next lecture. We will discuss BLU. Very important, my dear, very important, right? Very important. Basic length unit. Basic length unit. It is what? It is a basic length unit. So we are going to discuss is this topic in the next lecture. So thank you very much for watching this session.